Alright, so on the other screen it's going to be recorded. Do you see the Golden Gate Bridge problem in front of you? If you could just give me a thumbs up or an OK in chat so I know. Yes, okay. Amanda, can you see the screen that's being shared right now? And William, can you see the screen that's being shared? Okay, great. Also, what's useful is please find the annotate button. And so you can draw on this screen at the same time when I work on it, so you can participate with today's task. Okay, so try to give it a scribble. It looks a little weird on mobile, but you can still do it. Find that feature in Zoom. It should be enabled on my end. Great. So a person is using black color. Show name of annotators. Yep, someone chose the red color. That's great. Okay, melodies in purple. Cool. Rat in the sock. Were you able to find the annotate? And Amanda? I'm unsure. Great, rat in the sock. So it just leaves Amanda. Amanda, do you have a color? I'm red. Okay, cool. So I'll zoom in just a little bit. Okay. So where's my pencil? Here it is. Everyone except William, can you label? So in this problem, there's some points that we need to label so that we can solve it, right? Here's a point that's going to be useful. Here's a point that's going to be useful. Here's another point that's going to be useful. And based how the problem's organized, can you tell me what the coordinates of these 3 points are? So just fill in the blanks with your annotations, and then I'll write it in so it stays. What are the coordinates of those 3 points? Good, rat in the sock, you got the easier one. Amanda, Melody, any ideas on the upper 2 points, what they should be? Ah, Victor, hello. Good. Yeah, it's a little weird drawing with a mouse or a trackpad, but yeah, I can make out those numbers. That's correct, Melody. The x-coordinate should be negative 21, 0, and the y-coordinate for the left-hand side should be 500. Amanda, are you able to write on your phone what is in the right-hand side, what those 2 coordinates are? Cool. Positive, great. Yep. And so for this one, how did you get 2100? Melody or Amanda? Great. And so Melody, that is the correct math. Can you tell me what property this makes use of? So you can type it out. What allows us to figure out that part from a parabola? Yes. So Amanda here divided by, divided by 2, correct? So how did, where did the divided by 2 come from? What property of a parabola lets us do that? Yes. So there's symmetry involved. That's exactly right. I'm going to write in those numbers that you all did so they stay. So Melody wrote over here. Yeah, there's symmetry involved about the center of a parabola. So positive, good. And so Melody, good job on writing negative because it's on the left-hand side. Okay. I'm going to clear out your annotations. Where is it? Oops, my bad. One more time. Sorry, clicked the wrong button. Okay, so that's what you have written. Sorry about that. And Melody said that right here, right? What allows us to divide by 2, as Amanda noticed, is that thing is your axis of symmetry. So the span, right, your equal parts away, it cuts this 4,200 in half. And now you have 3 points. We can go ahead and solve for your equation. And did anyone get started on solving for an equation for this parabola based on these 3 points? And if so, you can just write it onto the screen. We can also, if someone got to it, work on part A if you want to write down the answers for that. Either type it out in chat or write it on the screen. Both would be good. And maybe after like 20 seconds, if there's no writing, then I'll talk about it. Okay, so let's see. There's 2 ways, right? First way, we could use, we can use, let's do purple, use factored form, okay, which looks like y equals ax plus b, and then x plus c, okay? We can use this form to figure it out. So y equals a, and in this case, we only have one x-intercept. It also happens to be our y-intercept. So x minus 0, or plus 0, x plus 0. It's still an equation, it's still a quadratic, okay? Ax times x, so y equals ax squared. And notice that we could have gotten the same result if we say use vertex form. So that's the newer form of a parabola or a quadratic. Y equals ax minus h squared plus k, where h comma k is your vertex. So both equations will lead you to the same spot because 0, 0 is your only x intercept, minus 0 squared plus 0, you can see that we have the same result. And now at this point, we have to solve for this a value. So either way, okay, either from here or from here, solve for your a value. And so we will use either one of these points. I'm going to choose this one on the right-hand side. As long as it's a point on your parabola, you can figure out what your a value is. And it ends up being some kind of really small decimal. So there's your x value, there's your y value, 500 equals a, and then it's, 2100 squared. So divide this by 2100. Divide by 2100 squared. Those go away. You get an a value that's equal to 500 divided by 2100 squared. And this small thing, 0.123113, 379, if we wanted to be precise. So then we have our equation. It's y equals 0.00113379 x squared. And so in this equation, let's see, switch to this color, right? We're on to part A now. What does f of x represent? What does x represent? Remember that f of x is just like y, okay? F of x, which equals, we treat it just like y, it's our output, represents the height off the ground. Right? X represents So that's like this distance, okay? Notice this side it's negative, this side is positive. So x represents the distance from the middle. And in this case, like left means negative, or going this way, okay? That's why it's like -1 feet, you went 1 foot to the left, 4,000 something feet, that's going left, and then if it's positive, it's going this way, okay? So that's what x represents. And now we have one sense of what does a represent, okay? A represents the width or wideness of parabola. Okay, that's like this whole thing. Notice our parabola here opens up really wide. If you just had like a equals to 1, you'll have a parabola that opens like this, y equals x squared. If you had something that was like bigger than 1, y equals like 10x squared, it grows really quickly, kind of like what we studied about exponents. It would be really narrow like that. If you had y equals 1000 x squared, it would be even more narrow like this. Okay, but all of those equations, they share this same vertex, but they grow at different rates. So I call that the width. Okay, and notice this one, the one that we're interested in, it's really wide, so that's why you see it grows so slowly. Okay, that's the a value. So we have a problem that explains it in context. Questions so far? Nope. For part B, it's a little weird. Solving it isn't that hard, but understanding what it wants from us is a bit trickier. So as I zoom out, right, this Morrow fellow was an architect who designed the lights in the Golden Gate Bridge. He only placed some lights along the bridge cables to keep it looking elegant. So it's kind of like this, or like that, going this way. Find the height of the cable halfway between the middle of the bridge and the tower to find the height of one of the light bulbs. So he hung like a horizontal bunch of lights going left and right, like that. And it's this first part that we're really gonna dissect, because there's a lot going on, especially if we mixed up our x's and y's, which is why they asked you about them in the beginning. Okay, you'll probably solve a different question. So the height of the cable, right? So when we see height right here, height and height, we know we are looking for y. Looking for y or f of x. Okay, because we just said right above that that's what the height represents, height off the ground. How far are the lights off the ground? And then go back here. Now we dissect this part. Okay, halfway between the middle of the bridge and the tower. Right? Where's the middle of the bridge? Well, that's over here. To a tower, it doesn't matter which one we use. Maybe we can use the left one on this side. Okay, so halfway between here. Notice I'm moving left and right. I'll use red. So we're interested in where the lights are at like this point. No, that's not right. That's not half. That's more like half right there. Okay. What's your y value over here? Imagine them going across. Well, let me redo that, because like you're not gonna have any lights hanging on that side. It's more of like between the parabola. You're wondering, okay, what is this bunch of red dots? How high is that off the ground? And on this side, making use of symmetry, let's see, okay, roughly halfway. At that point, we could have done that too. And that's what makes this part of the question hard. All right, so far so good? So keeping this picture in mind at the very top of my screen, we're going to utilize this equation that we made and then solve for y. Halfway, right, this kind of drawing that I did, what's halfway here? Again, that's like cutting. You know that this side is 2100 meters. Again, we divide 2100 by 2. So then we get 1050 feet. That's our x-coordinate. We use that in our equation. Y, since that's what we're looking for, that's the same as f of x, equals 0.000133379 times 1025 squared. And if you plug that into your calculator, you'll see you get 125 feet. That's how high a light bulb is off the ground. All right, so that's parts A and B. Questions? No? All right, so in the meantime, for tomorrow, you may want to look on to this problem about baseball. Let me just go away. Oh gosh, okay, my iPad froze. So you're gonna make use, if you have some time, look over the second problem up here. Is it a home run? It also has to deal with parabolas. Notice the path of the baseball, it goes up and then falls back down. That's parabola, it's a quadratic. Try to solve that, and then tomorrow we'll focus on diving through this problem. If you want another challenge to this, in the original problem, it said that it's at 0, 0, but we can change it up to make it a little bit harder. What happens if your vertex is now still at 0, because that's where the middle is going to be, okay, and you had it maybe 100 feet off the ground? And then could you still figure out the width, and can you still answer these other two parts of the problem? And where would the lights be then? If the vertex, the middle, was like 100 feet off the ground, your parabola looked more like this. And it makes the algebra a little bit more interesting. We can try to solve that, and we can also talk about that version of the problem tomorrow. Okay? Rat in the Sock, Amanda, Melody, we good? Yes, great. Awesome. Okay, that's today's lesson, short and sweet. I'm sorry that breakout rooms didn't work too well based on your setups. We'll try to improve that. I'll keep that in mind. If I put you into groups, then I'll put it into a group where someone can like share their screen so you can at least write on them. That's for next time. Okay, and then provide me any feedback, Amanda, especially for you since you're on your phone, how well this works and what I can do to improve your experience. It was good. Okay. And if you miss it, I did record it, and it will be posted up onto YouTube. Be sure